Hi everyone, welcome to my YouTube channel for the Atari 8-bit home computer. My name is Steve. I'm going to be the guide here. And for those of you that actually been continuing this session already, what I've decided to do is continue on with more assembly tutorials. And to kind of take a new approach, I'm going to use the Mac65 assembler this time to go ahead and write programs in it. And hopefully you can follow along with your type of favorite assembler, whether you have just a regular assembler or you have the Mac65 cartridge. Mac65 cartridge is also, probably one of the better assemblers. You can do a lot more with the programming side with it. And if you want to see, here is, well, here's my Atari 800 computer, and this is the Mac65 cartridge that's actually plugged into it. So that's basically all this is, just a plug-in. So this example, what we're going to be doing is I'm going to be showing you some of the programs I've written here in assembly. We're going to kind of start with a scratch program I have here and kind of work through some other examples and just kind of get you started on the way to learning some simple things in assembly, basically. It's not going to be a bottom line tutorial where I explain everything in vivid detail, but I'll try to make it a little bit easier for people to follow along that are not used to assembly and stuff like that. But like I said, this is my YouTube channel. Check out the other videos if this one is a little bit too advanced for you. I do have other more, Atari basic type videos that are more probably closer toward what you'd be looking for and easier programming. Let me get this started here. I'm going to kind of swing the computer around here a little bit and the camera to kind of show you the screen here. Okay. So this program I'm working on right now is a real simple one. Basically what it does, it's a joystick. It allows you to move the joystick around and change the colors on the screen. Notice my joystick just got unplugged here. And for those of you who need to know, this is actually the Atari Joystick in general. It's just like any joystick, you can move it up and down, left and right, and around, and all that kind of stuff. And I'm going to have it set so if you're moving it this way to the right, it's going to change one color of the screen. Move it this way to the left, it's going to change another color of the screen. And we're going to kind of do other stuff like that and see just where this kind of goes. So let me kind of move this back. I'll kind of explain this to you. First, let's run it. I think that'd probably be the best thing. Now, to run a program in assembler, you list it by typing list, but to run it in the Mac65, you just type ASM, usually that's the standard for a lot of them, and it'll symbol through the program, it'll list it to the screen, it'll show you all the, if you look over here to the side, you'll see the hexadecimal. This is actually the address where I've stored it at, and these are the lines it's picking up, but these are actually the hexadecimal locations of where the assembly code is going to be stored. If you've watched any of my other videos where you saw me typing in those data statements, these are the data statements, but they're translated here from hexadecimal. Oops. Okay, so I've got it in memory now, and what it done is it assembled into this memory location 800, and if you want to see what location it is, you just go down here and you type string or $8000, and that will show you the decimal location. So 32,768 is a safe place to actually store your assembly programs. So since it's already stored there, we'll go to DTT, and we'll set in the counter to the address that we just assembled it to, 8000 hex, and we just go to that address. It'll return back to the screen because we haven't located any graphics or anything or changing the screen. And we press the joystick and move it around here, and it kind of changes the border. See, that changes the border. This one kind of changes the screen individually. Any kind of color you want. Just basically what it's doing is it's picking random numbers and it's moving them into those joystick coordinates. So let's go back to the program now. Time to explain it. Okay, so the first line here, 632, this is the joystick memory location, and I've showed this in several videos already. This book that I actually use is actually called Mapping the Atari. You can get a lot of the assembly addresses and stuff into it, the memory locations. And the one we're using here is for 632 is actually this memory location right here, which is the joystick. Basically, it just initializes the joystick. And you see the 11, 7, if you look there on the left, those are the joystick positions, and those are the diagonals from 10, 6, 9, 5. And you see 14 is up, 13 is down, 11 is left, and 7 is right. So to kind of go back here again, this will kind of explain this now and kind of make a little bit more sense. So it's saying check the joystick to see if it's been moved to in the 7th position, and that means compare to see if it's at 7, and this is the immediate value of 7. And if you look over here, I got my little notes here. It says read joystick, moved it to the right. So if you moved it to the right, it's going to jump down to the label called right, and then basically at this point it's going to take load the cumulative 53770. I'm going to show this in the book again for people who are kind of new to this. Right here, memory location in 53770 says, when this location is read, it acts as a random number generator. It reads the high order bits of the 17-bit polynomial counter for the value of the number. And basically, if you look there right below, it says you can use this location in the program to generate a random integer between 0 and 255 by print peak 53770. And that's basically what this is doing, is randomly setting a number between 0 to 255. And then the next location is 710, which stores the background here. So this whole background screen, not this part, but just the whole screen you're seeing here, that's actually location 710, and it changes the color for that. And this location is known as a branch back to. And if you looked at this in BASIC, if you're familiar with BASIC, if you see the go-to statement, that's exactly what this means. It means go to whatever label that you have set up, or whatever line, if you want to call it that way. And basically what it's doing here is it's saying jump to joy. So it's going to jump back to the joystick. And basically, if you've gone and you press the joystick over to the right and you're done, it's going to go back and read the joystick again, so you can see if you're going to press it again. The next line here, if you look, it says CMP number 11, or compare number 11. See if there's 11 in the accumulator. If there is, that means you moved it to the left, and we're going to do the opposite this time. Instead of going to the right, we're going to go to the left. But notice that they're identical anyway, except for the memory location. So when it goes to the left here, it's going to do the same thing. It's going to read a random number in memory from 0 to 255, and then it's going to store that in location 712. And 712 keeps track of the whole border around the screen, basically, and that changes the color for the border. And then once it's done with that, after you move the joystick to the left here, it's going to jump back to the subroutine called joy, or the label up here, and just kind of repeat and go back and update the joystick again. So we'll run it one more time here. Go to your memory, so you can just go straight to DDT, asterisk, and just rerun it again. Now that you've seen that, basically, so if I'm moving the joystick, you see that it's changing because it's updating this 53770 into the particular location of where I'm moving it. That one's the border, that one's there. That's basically kind of a fancy way to see your colors changed on the screen. You kind of see what's in there. I could also have it scroll directly through them. Ooh, I like that color. To kind of show you. Let's do that next. Let's modify the program. We'll move it up a step here. This time we're going to scroll. We're going to scroll in memory and make it change the colors as it's finding the particular counter in memory. So it's going to color and cycle through colors. We might even need to add with carry maybe 20 or 5 or something, so it looks very good. And I'll show you some of that. We'll do one at a time here, though. Let me kind of swing this back around here again. I really like that color. I wish the Atari would have kept that color. Anyways, it was too bright for some people. So, we're going to be changing our lines down here. This one is now, to make this a little easier for people to follow, I'm going to set these up at the bottom here and show you what we're doing. Is we're setting up, we're setting up basically declarations, or what's known as a directive here, for each of these locations. So we're going to set up the first one, and I'm just going to call it X1. Basically, X1 meaning to cycle through the colors for the screen, or maybe SCX1, that might be good. SCX1. And then we just set the byte to 0. That means start the location at 0. And we're going to do the same thing for location 712. We're going to name that one, I guess I just call it Y, and set the byte for that one. Okay? Now we're going to be using these up in our program. Oops. So this line is going to go away, and we're going to increment the value that we have now set up, or the register. I'm going to save some room here. So it's going to take whatever is found in SCX. Remember, it starts at 0, but notice this line says INC SCX. That means increment in memory the location of SCX. It starts at 0. If you increment it in memory, it'll become a 1, it'll become a 2, 3, and so on. That's how you increment it in memory. We're going to do the same thing down here to the 712. So this time, I guess we could decrement it. It doesn't matter if we can increment or decrement it. I'll explain that in a second. Oops. No, I wanted to keep this one. No, I don't. It's SCX. So what this one is going to do the opposite. So if it's at location 0 and you decrement SC, and I did put SCX, let me put SCY. We want separate registers for them. We don't want to lose one color over another, so we're going to use separate registers since we set them up that way. So what this is basically doing is say decrement the SCY you set up, and since we initialized it to 0, if you decrement it 0 and it goes backward, it's not going to be a -1. The way the computer looks at it, it's going to flip it back to 255. So it's going to reset the full amount that it can go to, which from 0 to 255 or 255 to 0. So it just kind of flips it back. So it'll be 255 and it'll be going backwards. So when we start pressing the joystick, let's see, to the left, it should have the screen going down from a bright to a very dim. And then the up is going to go from a dim to a very bright. Let's go ahead and test that. And you can also type in REN in Mac65, and that will renumber the program, put it in order for you basically. And it'll reassemble it here. Make sure there's no errors. It'll give you error messages in Mac65. Let's go here. Now we're going to move the joystick. As I'm moving it, notice that you probably can't tell because it's going very fast, but it's actually incrementing through these one by one. We could set a delay counter in to slow it down, and I'll show you that in a little bit. But it's actually incrementing in memory. I'm moving the joystick so fast, it's not having time to really show you that. Now if I move it the other way, it's the same thing to border, except it's going backward and it's going down. But it's going so fast you can't really tell that it looks like it's incrementing. Look, if I hold the joystick, it just flashes the screen. That's how super fast it's moving. Okay, so let's go back and set a delay counter for this, so we'll make this a little bit more interesting. I'm just looking up a delay counter I already have here, so I don't have to think about how to create it. Okay, so what we're going to do now is we're going to set up a delay function for this, and it's going to jump to the subroutine while it's in here, and while it's here it's going to jump to the subroutine and update the delay so it slows down the program basically. So I'm going to set it at line, it doesn't really matter, you can put it anywhere, I just set it at 251 I guess. Delay 252. I'll explain this in a minute. Let me just go ahead and type this in. Let's see. Register. Back here, this one. Maybe this one goes back to the same place. Let me just double check that one. Oh no, this one goes to the next line down. Okay, if I've done that right, it should be correct. There's that 1, 1, 2 to make more sense now. Like that. Oh, I know what I did. I don't want to do that. Let's see, this one is going to jump back to, I think that's correct. Okay, and then once we're done with it, we're going to return from the subroutine. Let's renumber this. Oops. Okay, now I'll explain that to you. Okay, so what this is basically doing is setting up a delay loop. It's going to, basically it's a way of incrementing in memory until a condition happens. And this is going to increment through several different registers from the X and the Y register. So first it's going to load the X register with 0, and then it's going to load the Y register with 255. The next command here says DEY. It stands for decrement the Y register. It means to make it go backwards. So if it's at if Y register right now is at 255 and you decrement it, it's going to be at 254, 253, 252 going backward. And this one stands for B&E, stands for branch is not equal. So the branch is not equal. We're going to return to a label we called LP2, which means keep incrementing that register backward. Now you don't want to make it go back here, because if you do, it'll always get stuck at 255 and you'll be stuck in an endless loop. The next register here says DEX, and that stands for decrement the X register. After this we have another branch is not equal. Go back to LP1 and basically update the Y register again. Now a lot of people might think that this is still going to be stuck in a loop, but if you pay attention here, it says DEX. So it's basically decrementing this X register now. Since it's at 0, it's going to be going backward. Remember what I told you earlier about the flipping. So 0, flip it backward, 255, 254, 253, now it's going backward. And this won't keep it in a trap because it's still decrementing the X register. So it should work correctly. And what we're going to do next is we need to implement that into our routine up here. Instead, anyway, I can just set it right here. And then you're going to jump to the subroutine. I'll show you that in a second here. JSR delay. So what that means is jump to the subroutine that's called delay, which we have right here. It's going to go through this, increment this loop. Once it's done, it's going to hit RTS, which is return from the subroutine. And once it returns like a go sub and basic, it will go back to where it left off at. So basically it will return to the next line and continue to update that function. Let's move it down to the next one, or it's up here, I'm sorry. Memory number. Now let's assemble this, make sure there's no errors. Going to check it. Now watch what it's doing. It's actually cycling now through the colors, but it's doing it very slow. Where before it was going super fast, now you notice it's going very slow. Same thing with this one. It'll start bright and it'll go back to dim. So see, it's going down through memory. Now you can actually see the colors changing, where before you couldn't, because if I pressed the button, it could have already jumped like 50 different increments in memory. That's just how fast assembly is. So this kind of way to slow down your programs, which is necessary. If you've ever seen the game I have on there, I have a game on my channel basically, and that game had to be slowed down to be able to see anything. If I didn't set a delay in that program and I go to move the man on the screen, you would not see him. I mean, he would be moving super, super fast. And I can demonstrate that with a program here we'll do in a minute. It gives me an idea. So I just jumped out of it. So I'm going to save this. One is called Joy. To save, you just type number D, Joy, and the extension. Okay, so I'm going to jump ahead here a little bit. We're going to add to this routine, since we have the joystick now. I'm going to create a player missile graphic on the screen. We're not going to update anything with them because that'll be a little bit more advanced for people. I'm just going to create a bar going down in the screen that we can move with our joystick instead of updating the colors. We've already got our registers, so we probably don't even need to set those up. We just need to call the player missile graphic, initialize it on the screen. So what you want to do is you want to do it at the very beginning here. I'll just set, you know what, actually let's do this inside the loop and let's do this one outside the loop. So we'll say 65 or 61 and player missile graphic. What we're going to do is we're going to initialize the color we're going to initialize the size and the location. So let's do the color. The color could be, I don't know, 52. And then the color for the player must graphics stored in location 704. And then we're going to do the location just to start up. Store at 53248. And then we're going to do turn it on. Oops. So let's renumber that. Let's go ahead and run the program now and symbol it in memory, and we'll see if that bar shows up on the screen first. Okay, so there's the bar we're going to be moving in a minute. Now, if I press the joystick right now, it's only moving the screen because we still have the screen set up in memory. So we're going to change that, so if you press the joystick, it's going to start moving this bar around in the screen. I'm going to do one or two things. First, I'm going to leave it with the delay and show you how slow it is, and I'm going to take it out and watch how fast it is. Okay, so we update. It's a simple change. You just take the color and you put in the number 53248. That's the horizontal location. I'll comment that over here for people to know. Whoops. So it's the horizontal position of the missile. I put 1. It's actually 0. To be politically correct, that is. Okay, so we're going to do the same thing with the other one down here. Let's go ahead and renumber this. We're going to take the 712 here, and we're going to put the 53248 in this location. Now the thing about here is I have it at Y right now. So if you're moving the joystick though right now, it will still work, but it's going to be updating 2 different registers. So since we want to move it backward and forward, we're going to use the same register for SCX only. That way it'll be able to move it SCX in the negative direction or in the positive direction. Hopefully if everything looks correct, it should work correctly. We'll reassemble it. Another trick I wanted to show you too is that if you go up here at the top, you see where it says OPT.obj. This is just how the computer assembles information into memory. Now if you don't want the listing to show, you can just type this. OPT.obj, and after you just type no list. And that will still assemble it into memory, but it won't show your listing. And actually, you know what? What did I do wrong here? Oh, probably has to be on another line. The OBJ, the no list. Well, it's not doing this correctly. It's supposed to actually let me do this after. I think it's probably where I put it or something. Maybe, oh, I think it goes down here, if I recall. So we're going to 12 number and see what it looks like. Well, maybe I'll show that in another video. For some reason, it's not. I'll pull up another. I don't have it memorized. I'd have to look it up on Google, but there's a way to do an OPT and OBJ no list, and it'll stop the listing from going to the screen. But anyways, let's run the program since we've got a symbol here. Okay. Oh, I probably forgot to set the location. It's actually at 0, so you can't see it moving right now because when I move the joystick, remember we set up for SCX at byte 0. It's starting it at 0 and it's moving it very slowly, so you probably won't see it on the screen unless I hold my joystick here long enough. So I need to center it on the screen. There it is actually. So look how slow it's going. You see how slow it's going? I mean, we're going to be set up to go a little bit faster with the delay. And like I said, eventually I'm going to take it out and show you how fast we can make it. I want to save this too just to make sure I don't lose anything. We'll call this one, I guess player lithographic is good. So what I'm going to do is I'm going to modify the delay this time so we can kind of speed it up a little bit. And to do that, basically you just change this number right here for 255 and you drop it down like 55. That should do it. Now let's change this one to put this back on the screen. So now, just drop my pen. So now, what's going to happen here is it's going to start the location at 45, which should be on the screen here instead of where we had to come onto the screen earlier. So you should be able to see it on the screen immediately when we run it. Oops. So see, it's on the screen right away this time, just like it was earlier. And we got to move the joystick, and it's moving a little bit faster than it was, so it looks a little bit better. Maybe for a game you might want to make it just go a little bit faster. All we do is we just basically change that delay counter again. I'll set it to something like maybe 15. That should do it. I usually do something like 15 in mine. There we go. You see how, you notice how it's getting faster each time? Now watch, I'm going to take out the delay and watch how fast this thing is going to move. For both, you got to take it out for both sides. I think I just remembered this one too. Might be no less maybe. Screw it. Maybe it's OPT no less. Let me just try that. Probably no, probably just OPT no less. Let's see. That's the one. So that basically turns off the code. So let me go ahead and before we do that, let's go ahead and turn off those delays. So to turn them off, we're just going to comment them out. Watch right here. To make a comment, you just put like a semicolon beside it for each one. This one too. Okay. That's good. Let's run it. Now you see it on the screen. I haven't moved anything, but watch this. That is the missile moving. That's how fast assembly is. Look at that. I can't even see it. I can't even see that with my eyes. It's moving so freaking fast. Can you believe that? That's actually it, moving. But it's moving so darn fast. There's no way. If I go like that and tap it, you might see it. But if I hold it, it's moving super fast. There's no way to even see it. That's why you have to set delays in assembly. What's really cool is to really watch something like that in action before you set up a delay. Isn't that pretty amazing how fast that is? Gives you an idea of the difference between basic and assembly. What you're in for. Some other things we could do is we could change the color of this if you want. Nothing real fancy here, but you can just change the color right here with this number. I think 72 might be an interesting color. Let's see. Like a pinkish now. Like a pink blurry line on the screen. Let's slow it down a little bit more too and see what happens if we kind of put the delay back in. We'll set it as possibly low as we can get it. Which is, well actually that would set, let's see, 255. So this one starts at 255. This is decrementing the X register, so it's going backwards. So probably set this one to 1. And this one maybe to something like, let's try 255, see what that does. We'll just try that for purpose's sake. We can get it to do anything else weird. Yeah, it's moving a little bit. You can kind of see it now, but look how fast it's still moving there. That moving line's moving across the screen, ain't it? So you can move it that way and that way. But earlier when I moved it, you couldn't see it. It was moving so fast once we took out that delay. That was actually how fast the processor was moving with that line. That's one of the, like I said, it's one of the advantages and one of the reasons why you should really learn assembly, because you speed up your programs and make them look so much more cooler, the way I look at it. Let's save this one. It's only a half hour. He's trying to see if there's anything else I can tell you here. see, we got it moving left and right. We can't really like program in the up and down movement because it's just a line right now. Now, I showed you in other videos where we can actually change that player muscle graphic into something else. So let me load up another program I have here that's actually like a mini game. Give me a minute to find it here. If I can remember where I stored it. Let's see what this one is. This is actually the beginning of my Dead Man program. Kind of how it started. I think this might just be it might be part of the game. Let me see. Well, it's taking a while to load this one in. Yeah, what location is this one at? Oh, it just wiped it out. Let's try this again. It's even loading it. Okay, so there's nothing on that one. Let's that file got corrupted. Let's try this one. There we go. Hey, this is the Dead Man one. Let's see. Yeah, this looks like my Dead Man game. I guess we could use this one. We could probably just take it apart or something. Got some error messages in it. Let's skip that one. I'm not going to fix that one. It's too complicated to fix that right now. I do have one set up here. It's like a shell that we can work off if I can just find the disk for it. Let's see what's in this. Okay. That's it. That's just while you guys are waiting. I'm going to look at that. I'm going to be looking for the other one here. It's this one. Yeah, I think it's this one. I just had the wrong disc. I think this one will work. Yeah, this one should be fine. This is actually the one I wanted to show you. Actually, my man's up here. There he is. Okay, so this is my little character man I have on the screen. And I'll really kind of go into this program to explain. See, this is how you can kind of make up a simple game, and this is how actually that game started before I put anything together. So basically you have like a little level here. It doesn't do anything when you go off the screen. And I wanted to use this as a shell to kind of see if we can maybe change some stuff with the character and maybe start adding different stuff to the screen to kind of give you a shell to work with to build your own games and stuff like that. Okay, let's go back to the program here. Oh, it's right here. Right here, I believe so. Oh, it's down here. Cast it again. Remember earlier when you saw the other video with the joystick. Here's how I'm reading the joystick in this one. It's just reading a subroutine. When you're making a big game, you use a lot of JSR to jump around in your program. In this one, I'm updating the joystick, or you might be updating, for example, like the collision. You might be updating moving objects on the screen, vertical blanks, a lot of different stuff. So you would use like a JSR, and I could see where this thing is at. Example. I'm just searching for where the label's stored at. It's right there. It's a 2000. I was almost to it. Right there. So it's jumped into the subroutine for this one, and this one reads the joystick positions in like we done earlier. The only difference here is we're using the AND to bit mask the values, and this is another way of reading the joystick. And this one just shows you right here. This is the up position, this is the down, this is the left, this is the right, and this is the fire button. So, trying to think of anything we could probably do with this program. We've already got the man moving around. We could maybe we could add like another level to it. Like you have that one level, we'll add another level, maybe a higher level or something like that. And I'll show you how that's done here, as soon as I can find out where I stored it. This is just all the main setup right here. There's the graphics setup. It's down here somewhere. Here we go. So this is the main subroutine where all of everything is being called to, because this is basically updating the graphics screen, and this starts to draw in the levels and stuff like that. So what we're going to do is we're going to draw another level that's very similar to the one we saw on the screen. I'm going to probably put it right after this one. Put it right here, I guess. Got to get the color in. Okay. So if you look up here, you see this number 66 plus 160. I think that might be the level. We'll try that one, see if it's at the ladder of the level. It's reading it at character and memories, what it's doing. I'm going to try it without the 160 and see what that does. Let's see, what did I do? JSR. Oh, I should put it here. Okay, so this next one is the X register. Let's see, we got the level going from 12, 18. And so it's plotting from 12 to 18, and it's drawing over from 12 down to 16. So this looks like this is the ladder. We probably don't want to use that one, so maybe 66 might be it. We're going to start this at 0, and we'll have it down. So this 0 is basically telling how far over you want to plot it. If you put it at 0, it's going to start over here, so we can draw it across the screen or do whatever we want with it. So I'm going to set it at 0, and I'm going to set it a little bit higher, to make it look like kind of like a higher level. And we'll set it to probably about 5 or so. There's our plot. And do the same equivalent. Oh, I almost forgot. Let's give it 0. And JSR plot. Let's renumber this one. What happened here? Like my program just froze up on me here. I know what this one's doing. Oh boy, I wanted to show this to you. I think it's got too many lines in this first part. It's running into the, basically it runs into memory when you put too many lines in the assembly and you're not moving around the counters here. So let me see how many lines I have in this one. This is why I set it into separate files for include files and all that. Might not even be able to use this one. Let's see, it's probably going up to like 7,000 or something. Yeah, it's going up to too many lines. So basically it went over the number of lines. Well, I guess we won't be using that one. But we might be able to modify and do some stuff with it for now. Let's try that. At least I can show you how it works. We'll move that ladder around, is what we'll do. So let me assemble this again, make sure everything's good. Let's run it again here. Okay, so what I'm going to try to do is I'm going to try to move this level around, maybe just move this up a screen or something like that, just so we can kind of start playing with some stuff. Actually, what I'll do is I'll raise this level a little bit and maybe make the ladder a little higher. Let's try that. So it starts right in here. Starts at 41,110. Over 0. That looks fine. Down 19, we're going to move the line up. So maybe set it at 10. And down here we want to keep Y the same. 10. And the ladder is down here. So we make the ladder connect to what we got. So what it's doing right now is it's plotting at 0, 10, 0, down 10 lines, and then it's going to, this is just for the plot, and then this next one is going to draw to, so it's going to take off from where it left off at 0, 10, which is way over here, and it's going to say, where's the X register going to? It's going over to 19, so it's going across the whole screen here, and then it's going to say the Y register is going to be at 19, so it's going to draw it down at the same level. Let's see, I think this might be the ladder. Let's see. Looks like it's going down on Y. 10, 19. This might be the ladder. Let's make the ladder higher. Set this down to, well, I never can't pass too much more. So 0, 19, and 0, 10. Go to the 19. And this one is 10, 16, so this is 21. That might move the ladder like that. Let's try that. Look. Oh, great. Good. Well, yeah, this one's overflowed. I'm not going to be able to use that one. Sorry about that, guys. I thought that one was going to take us somewhere. Let's see what else I have on my disc here. That one was just too long. I know I saw another one here earlier. I'm going to do the draw screen one. I could probably play with that one. Since we're on the draw 2, let's just do the draw one and focus on that one. Still got about 20 minutes on this one to do something with it. So this one is right here. Okay. So have any of you ever seen my drawing program I have for machine language graphics? This is the one. I'll symbol it to show you. So this is one that draws lines on the screen. We could probably change this to do other different kind of stuff in general. I think I already have the clear option. Let me see if I press option. Yeah, option is to erase it. What I'm going to do is I'm going to try to speed up this line, see if we can figure out a way to make it speed up by taking out the delay and see what happens. We'll have some fun with it. First, let's find our delay. Right here at 1220. Now we start looking for every increment of delay. We'll start removing them. There's one right there. Might be the only one. Okay, so let's try it. I only had one delay in it. Okay, let's see what happens. Okay, so see how fast it's moving? Without the delay, we can see that it's moving very, very quickly. I'm going to draw some things here with this one. We kind of went over the delay and stuff earlier. So I'm going to see what else we can do with this one. Maybe we can increment the colors or something. Let's see here. Let me kind of study this one a little bit. Left, go right, go up, go down. Change color. Maybe I can change the graphics mode on this one. Let's do that. I'm searching for the graphics mode so I can go ahead and change it now. And it's right there. Down here somewhere. Okay, so where is it? Start. Okay, so here's the graphics mode we were using 7, so I'm going to move this up to 8. You know what? Let's do something else. Let's just try 1 maybe. I'll turn my delay back on. Is that 4,000? Where was that already? 1360. Turn this one back on so we don't have a super fast program. And we're going to change this one to graphic 1. And, well, let's assemble that. I'll show you. Watch what happens. I changed this to graphic 1, so it should go in graphics 1 mode now. Okay, so now it's in graphics 1. And in graphics 1, everything's going to look a little bit different. Gee, I wonder why this is not. Let's see here. Trying to see where it plotted the line at. At 0, 1. Might not be finding. You might not be reading the color on the screen or something. Let's see. I increment through color if I press the button. Color, there's 4 colors. We'll change this to 255. Let's see if that would work. Alright. There it goes. It's not moving the screen. Oh, so it's not plotting and moving this. Isn't that interesting? You see it's doing this, pressing the numbers, and it's changing the character on the screen there. Whether you can see it or not. But it's not moving yet. It must not be programmed in for some reason. So go left, let's see what go left shows. Increment X1 move, plot me. X1 new, LY. I'm just trying to see why it's not drawn like the other one was. We switched graphics mode, we can get it to draw again, but I'm just trying to see what happened in this one. Might be drawn off the screen or something. 70X1. So it's getting pretty close to an hour. Maybe we'll throw in the towel here in a little bit. I just wanted to see if I can change anything in this to make it look better. I'm going to turn the color on. It's going to change anything, we're going to find out. Well, that's really weird, isn't it? Now we change the graphics mode, it'll move it again. This time. Change it to 8. Unless for some reason we turned off the movement somewhere. Maybe we did. Huh. I don't need to do nothing. Okay. That's certainly interesting. Oh, we're not overflowing again. Very strange indeed. Let's put it in graphics 3 and see if that will move it. It just may not like those plots and draw twos in other graphic modes. Seem to be restricted to one graphics mode here. It changes the colors, doing the same thing again. How very bizarre. I'm going to put it back to graphics 0 now. I notice our plot is actually happening here, and this one I press the button is changing the color, so I don't think it's centering correctly to be able to move it or something on the screen. It seems to work for graphics 7. Let's see if we can move that down to 6 or something maybe. First time I've seen anything like this. Maybe even move it up, maybe 9? To play with this one later, 9 doesn't seem to work. It's very strange. Let's try 10, 11. We'll try 11. 11 does not want to work. Got me curious now. 12. Well, 12 seems to probably do the same thing as the other one. Still won't let you move it on the screen. I think since this one's getting close to an hour, I'm going to go ahead and throw the towel in on this one. Sorry about that, guys. I thought we'd be able to change this one, but see, assembly programming takes a lot of time. Sometimes you really have to go through stuff and see what's going on. I haven't played with this program in about a couple of years or so, so I really don't know the full gist of what it's exactly doing. I've been trying to guess and change stuff in it. Let's see here. It's gonna really bother me wondering why that did not change that screen. This is actually controls the graphic mode right here. Notice I have a VBI in it. Let's see that VBI is connected. The VBI is connected somehow. No, it's not hooked up. Let's see. Well, I'll probably have to plan these a little bit better in the future, but I guess you can see from the first video, the very beginning, that we had some fun with this and kind of took it a step up from beginner to advanced, I know, but generally that's what you're doing with assembly is you're always trying new things, learning new things, and that's the great thing about learning to become like a game programmer and stuff is you really don't let anything put you away from what your goals are, and don't be restricted by anything in general, and just see how far your mind can stretch you, see what you can really learn to accomplish with your computer. So I wanted to load up that other program one more time here. Oh, you know what? I moved the disk and I don't remember where it is. That's on the top here. Let's try this. Well, I lost where it was at. I wrote it down and I lost it. Let's see. I know it's on that one disc or it's on the other disc. Let's try them both. I'll try this one, I think. N65. Not this one. I'll put this disc to the side. I'll try the other one. Well, I think I lost the disc. I stuck it over here somewhere. I see the wrapping for it, but I don't see where the disc went to unless it fell on the floor or something. I think I'm going to go ahead and cut that one off so we don't have to sit there and waste all the time me trying to find the disc. But I was hoping to be able to load that up and show you a few other tricks, but I guess it's already into an hour here, so we'll just kind of let this one go. Sorry this wasn't the greatest video. I don't really plan these. I just kind of go through it, work it through as I go through them and see what the outcome is and everything. So definitely go ahead and subscribe if you're interested. I do have a lot of good videos up there, and I'll still keep working on other ones. Maybe I'll start planning and putting together a game design in N65 to teach people step by step how to do some real game programming and stuff like that. We'll start with simple stuff like we saw on this screen and kind of learn how to move a man around, and we'll kind of work our way up. I'll have to build in general, I'll have to build a shell or something to be able to do this with. My programs in general are already built from the ground up. So anyways, thank you for watching and have a great day.